Hi, everyone. Welcome to Nexus Intelligence Insights. My name is Elisa Velarde. I'm a Senior Product Marketing Manager here at Sonatype. And I have with me today Ax Sharma, my
Hey
partner in
everyone.
crime when it comes to this data security research. Thank you, Ax, for taking the time and for being with us again this month. This month we have a PyPy vulnerability, a information exposure network denial of service type of vulnerability, as I said, for PyPy. Basically, this involves MAC address table aging or not aging, as the case may be, and what we might be able to do about that. And then some of the other, besides denial of service, some of the other types of attacks that could be leveraged because of this oversight in the configuration. So just to give a little bit of background here, this was a well-meaning upgrade for back-end capability, network capability that ended up breaking Linux bridge, if I got that right, Ax, keep me honest. Essentially set aging, MAC address table aging to 0, which created a lot of sort of network chatter and those kinds of things. So I'll stop talking now, Ax, and let the expert take it away.
Expert, if you say so. So let me just share my screen here, Alyssa. As we can see here, the vulnerability CVE-2019-15753 concerns OpenStack OS5 component as present in PyPy downloads. And let's go into, since this vulnerability is a networking issue, right? It affects switches. Let's go into a little bit of just fundamentals first. So the way how switches work, right? Say there's a host A and host B on the network connected by a switch. If host A wants to send a message or a packet to host B, it goes through the switch. And this is the stage where switch will record that, okay, host A is present at port 1 and is trying to connect to host B present on port 2. And when the second host B responds back, the switch will keep a log of that. And this process helps create what's called a MAC address table. This is how switches can keep a track of who is sending messages where on a network and how to reach those devices. Now, the problem with this vulnerability, let's go into this. What it did was developer disabled this process automatically. And since
So
a
this
MAC
was a
address,
hard-coded type of change to the code, just basically making it,
absolutely.
okay, gotcha.
Yeah, so the developer, to enhance performance, to answer your question, Alyssa, to enhance performance on OVS implementations, they disabled this, like hard-coded it to 0, which prevents MAC address relearning. And they did it to, as it says over here, to prevent packet loss on some migration edge cases. I'm just reading off of there. And what that did was in Linux bridge implementations, right? Because this MAC address relearning was disabled, this has two implications. First of all, as we see here, right? Now the switch would no longer know what's the updated port for a certain device, say in case of a configuration change, right? So this is a rather simple example, but on bigger network configurations, say host A was sending packets to host B, right, from port 1, and like host A is present on port 1 and host B is present on port 2. In case of bigger network configurations, if there was to be a change and these two devices were swapped, now the switch no longer, because the MAC address learning was disabled, now switch no longer knows this. The switch is still going by the old entries that host A is present on port 1 and host B is present on port 2, whereas this may no longer be the case. Now there's two implications to this. Firstly, packets are not going where they're meant to go, and this causes network delays, performance issues. But the second critical issue is, of course, potential information exposure. Something meant for port 1, or rather, I should say, host A is going to port 1 where it's no longer host A. It's a different device that's present at port 1. So this was the implication of this change.
Fantastic. So talk a little bit more about the sort of the security implications around this. What could potentially happen if the MAC address learning is disabled, and somebody knows about that and is able to leverage it? What might be the outcome of that?
I think at best an attacker can maybe congest the network, right? Just keep sending packets when they're not going to go to their intended location. But the switch, because of the dated network, dated entries in the MAC address table, will keep trying to just broadcast those packets. And obviously, if someone's smart enough, they may be able to, grab packets. So packet meant for device B is still going to the same port where device B or host B used to be, and a different device may be able to grab those packets. I'm keeping it simple, keeping it at layer 2 level. So
Makes perfect sense. So talk about remediation guidance here. What would you recommend in terms of remediation for folks who might be using this particular vulnerable component?
yeah, absolutely. So at the time we researched this vulnerability, the fix was not released. So we actually caught up to this vulnerability pretty fast. But right now there is a fix available. It's in version 1.17 of PyPy downloads for OS VIF components. So that's the version people should upgrade to.
Thank you so much, Axe. It's always nice working with you on Nexus Intelligence Insights. If you'd like to scan your application to see if your code is vulnerable, you can do that by using the Nexus Vulnerability Scanner. The link is below in the blog. If you have any questions, feel free to reach out to either Axe or myself. My name is Elisa, and we'll be happy to help. Thanks so much, and we'll see you next month.